Alrighty, so today, listen carefully. We are going to be adding and subtracting radicals. What you need to remember when you do this is to not try to get fancy and not make up math, okay? You treat radicals like you do variables, okay? You have to be able to combine like terms. So if you look at number 1 here, number 1 is super easy. This is like negative 8x minus 6x. You don't do anything with the square roots. They're just along for the ride. So if I have negative 8 of them and then I subtract 6 more, what does that give me? Negative 14 square roots of 10. Think of them as things. Those are things, okay? That's how many square roots of 10 I have. We good on that? So if I look at number 2, can I combine them like they are right now? No. So, but that doesn't mean I can't combine them. Now, it is a possibility that I still can't combine the two terms, but I need to try to simplify what I can simplify. So we know how to simplify the square root of 50, right? What are two numbers that multiply to give me 50? 5 and 10, or 10 and 5, either way. And then 10 becomes 5 and 2, or 2 and 5, right? So the square root of 50 reduces to what? This becomes 5 square roots of 2, and then I can add 9 square root of 2, and that gives me a total of 14 square roots of 2. Okay? So you can only add and subtract like terms. I knew I saw you today. What are y'all trading IDs? Okay, but along with this, because there's not an example like this on here, and so I just want to at least address it. If I have the square root of 5 plus the square root of 6, I can't reduce either one of those, and I can't combine them, so it just stays the square root of 5 plus the square root of 6. Okay? Like, that is a possibility. You cannot always combine everything. Right? We good on that? All right, so then let's look at number 3. Square root of 40. What are two numbers that multiply to give me 40? 4 and 10. Okay, now I'm going to give you a couple of ways to do shortcuts, which some of you may already do. I don't know how comfortable everybody is with this, but if I'm doing square roots, now if I'm doing cube roots or fourth roots or something else, that's a different story. But if I'm doing square roots and I start branching off and I come across a perfect square, because 4 is a perfect square, I'm just going to box that thing, okay? And then 10 is 2 and 5, and then I'm going to circle those because that's what I've been doing. I don't necessarily have to do the tree all the way down every time. If I come across a perfect square, I know I can just take the square root of it. So I can't forget about this guy. I have this negative 3. I need to take the square root of 4, which is 2. These two do not have pairs, so they can stay underneath. Okay? You do not have to do these shortcuts. If you start doing that and you start making mistakes, then maybe you need to back out of it and not do that. Okay? But this term right here reduces to negative 6 square root of 10. Everybody okay with that? That's this first term. I'm going to change colors for the different terms. I should have given you more space. I wish I had given you more space. I thought it was plenty, and I was wrong. So then this, I don't want to forget that I have a negative, but I can make this 16 and 10, right? So then look what if you think about what you're doing and you know how to understand the numbers in your head, is 16 a perfect square? Yes, okay? 16 is a perfect square. And then 10, I literally just did this. It becomes 2 and 5. I have nothing else to pair it up with, so it's going to have to stay underneath, right? So this whole thing right here can end up being negative 4 square roots of 10. Again, you do not have to take shortcuts. You can do the entire tree every time. That's the safest thing to do. But if you understand the little shortcuts, do them. If you don't and you're giving me dirty looks like Jenny, then just go ahead and do the whole tree. Because I know you're sitting over there thinking, what the heck are you doing? Is that what you were thinking? You got it, okay. But that's okay. Because we talked about the tree yesterday, and I know y'all know how to reduce them all the way. So I'm just showing you some other little things and how to combine them. Then when I put these together, that's going to give me negative 10 square roots of 10. Okay. And the inside and outside number we know don't always match. Don't start assuming things. All right, so now here's one with some variables. Let's go ahead and break down 48. So I'm just going to take care of this whole first term first. What are two numbers that multiply to give me 48? 16 and 3. Okay. And why do you think he picked 16 and 3 and not 8 and 6 or 2 and 24? Because you already have a perfect square. If you recognize those numbers, that's great. If not, do the tree and you're totally fine. Okay. So this is a perfect square, and then that guy's all by himself. So this whole first term, it's negative. Don't lose your signs anywhere. I'm going to take the square root of 16, which is 4. Then I have that x cubed, and then that square root of 3 has to stay underneath. So, you know, some of y'all took different classes than other people and maybe have dealt with square roots more so, or even if you didn't, you understand them better. So if the person next to you is taking the shortcuts and you're like, I think I need to do the tree, do the tree. It's fine, okay? We just have to be able to get through them. All right, so then let's look at this one. Again, don't lose your negative there. The 3 is going to have to stay underneath, right? But I have x to the 6th. The index that I don't see right here is a 2, right? So I take the 6, I can divide it by 2 evenly. So I get a negative 2 from this, but then the 6 divided by 2, that gives me x cubed square root of 3. Now, when you have like terms, the whole thing has to be a like term, meaning that I'm not just looking at the square roots of 3. I also have a variable there. So this whole thing is what has to be alike. I have negative 4 of these things and negative 2 of these things. Gives me a total of negative 6 x cubed square roots of 3. What questions do you have? Anything? Y'all being naughty over there. Questions? Okay. Let's look at 5. All right, so I have a negative square root of 16. What's the square root of 16? 4. So this is just negative 4. Okay? I'm going to underline it because I'm going to have 4 terms and they might not all be at the same level here. 72. I can break that into, I'm just going to go ahead and tell you, 36 and 2. So I can shorten it some. Again, you don't recognize that, you do the tree. It's totally fine. So the square root of 36 is what? 6. And then because this is negative, what else comes out? I. And then this 2 stays underneath. This is positive. This is still positive. That negative inside the square root does not affect the sign. It affects the I. Okay, we good with that? All right. Then square root of 121, what is that? 11. So that's plus 11. Then I have the square root of negative 2. So what comes out of there? I, and it stays the square root of 2. Okay. So let me just write this out, what we have. We have negative 4 plus 6i square root of 2 plus 11 plus I square root of 2. So I'm going to have a total of 2 terms because I have these 2 that are just plain old numbers. What's negative 4 and 11? 7. And then 6i square root of 2 plus I square root of 2 gives me what? 7i square root of 2. Okay. Yes, sir. The square root being what? No, that's not okay. It's not simplified all the way. Oh, so you're saying if I left it square root of negative 2 instead of the I? Yes, no, that is not, that's not simplified all the way. Like, it's one of those things where you're not wrong, but you're not finished. Yeah. All right. Good question. Anything else? All right. Let's look at 6. What's the square root of 9? 3. Thank you. Somebody's paying attention. And then minus, what's the square root of 100? 10. But what else do I need? I. Thank you. Then I have minus, what's the square root of 36? 6. Then plus 3i. Good. So I don't have any square roots left at all, which is totally fine. But I'm still going to have 2 terms. I get 3 minus 6 is negative 3. And then that would be minus 7i. And as far as proper format goes, your imaginaries are always in the form of a plus bi. So the I term should always be second. Okay. All right. Questions? All right. Let's look at some with some cube roots. All right. Negative 4 times the cube root of 8. Now, if you know what the cube root of 8 is, that's great. If you don't, let's pretend like we don't, because maybe we don't. This is 2 and 4. I'm not going to box that as a perfect square, though, because this is a cube root, not a square root. So I'm going to make that into 2 and 2. Okay. If I'm doing a cube root, I look for sets of 3, right? So I can't forget this negative 4. So I'm going to get negative 4 times, and then these 3 2's come all the way out as a regular 2. I have nothing left on the inside because the cube root of 8 is 2. Okay, 2 times 2 times 2 is 8. Then, so that's going to be negative 8. There's my first term. Then I have minus, so minus, what's the square root of 25? 5. But what else do I need? I. So this guy is right there. Okay, we good on that? Are y'all even paying attention to anything I'm saying? Okay. I mean, I can't even keep you entertained with my wig, and you're not even paying attention. I look cute up here. Now, come on. All right. Then plus, and if you know the cube root of 27, that's great. You don't, we do the tree. 3 and 9. 9 is 3 and 3. So these 3's come out as a regular 3. And I have nothing left under the square roots. But I am going to have 2 terms because of the imaginary number. So that's going to give me negative 5 minus 5i. Okay. What questions do we have? Anything? Okie dokie. 64. Now let me show you something on this. Let's say that I know that I have 4 times 16, which that might not be how you, oh, actually, let me take that back. No, I'm thinking out loud here. I was thinking about how I wanted to do something. Well, it doesn't matter. But then this is a cube root. That's not a perfect cube, but 16 is 4 and 4, right? If you come up with something like that, it's okay that they're not reduced all the way. You're looking for sets of 3. I have 3 4s, and so I can stop right there and have the cube root of 64 is just 4. Does that make sense? So I'm not saying that might have happened with that one because you probably would have started with a 2. I probably would have also. I was just trying to show you something else. All right. Then we're going to, actually, I'm going to change colors so I don't lose you. Then we're going to do plus. Now here, oh, this is the one where I was going to do that. Cube root again. 10 times 100. So, and then this is 100, or 10 times 10, right? That gives me 3 10s. I don't have to go all the way down to the 2s and 5s. I can, and then I'll have 3 sets of 2s, 3 sets of 5s, and do it that way. But if I have 3 10s, that's enough. But look what happens here. I have this 4. I can't forget about him, right? This 4 comes out. This is a plus. These 3 10s will be a regular 10. But since this is negative and this is a cube root, do I have an I? No. The 10 is negative. Okay? Do we understand why? If you have an odd root of a negative, the negative comes out. If you have a square root of a negative, you get an I. Because negative 10 times negative 10 is a positive 100 times another negative 10 would give me a negative 1,000. So the odd root with the negative comes out. There is no I. Okay, we good on that? Square root of 36 is 6. And then minus, now we already did the cube root. Cube root of 64 is 4, right? So what's the cube root of negative 64? Negative 4. So that's minus a negative 4. So what I end up with here is 4 minus 40 plus 6 plus 4. And what does all that give me? It'll be a negative something, right? 26. Negative 26. If you didn't like the shortcuts I did, don't do them. It's totally fine. I really just needed to make sure you understood how to combine these so you're not making stuff up. Okay? What questions do you have? Anything? Okay. So your assignment is in Delta Math, so you have time to work on that and the one from yesterday if you didn't finish it. Y'all were doing a great job yesterday working together and asking each other questions, asking me questions, so make good use of your time.